Okay, I wanted to close out the machine learning module just by saying a few words about the case and about the discussions that I saw happening on D2L. So this case was an interesting one and very relevant because Netflix was famously kind of a leader of applying machine learning in a really beneficial way. They had a contest for many years where they offered $1 million to somebody who could come up with a better machine learning algorithm to predict good product recommendations, one that was superior to the one that they were using. And so they were very much committed to machine learning as a way of increasing the quality of the recommendations. So um, what Disney wanted to do was kind of like an extension of what we talked about in the first unit was they were examining where their competitive advantage was, and they wanted to see how machine learning could help them expand this advantage. And of course, Disney's big advantage is in all the intellectual property, all the characters and all the movies that they have created. So it made sense to them that given all of this IP, that they should join the streaming platform world and that they would have a unique advantage because they did have all this ownership. So what they were going to do was to take this advantage and then amplify it by doing what Netflix did and you know it kind of improve its recommendation algorithm because so that people would be more satisfied with what they got. So uh, Netflix, you would think, like when I think about, how important it is that I get a good recommendation, it doesn't seem like it would be that big of a deal. However, Netflix proved that it did make a big difference. So they use machine learning uh, to, based on movie attributes and the attributes of the watcher, the customer, and based on their similarity to other customers, they were able to give recommendations such that 80% of the viewings were based on recommendations. And what this meant was that people were getting the shows that they wanted to see. And Netflix also got ideas about how to make new content. What is it that people are looking for? And they can actually create those shows and movies according to those tastes. And the interesting thing is they didn't do this by kind of identifying the characteristics of blockbusters. Because streaming is cheaper, they don't really need blockbusters anymore. That's kind of a theater thing. What they wanted to do was identify these so-called taste communities, and they made movies for these taste communities. And they were able to identify, what were the characteristics of the movies that appealed to these particular taste communities, and what taste community is this particular customer in. Um, and so the result of this was that because people would see shows and then like them because they were made for the taste community, new shows were picked up for a second season at 3 times the rate of shows given to other networks. And so so the shows were more successful because they were designed so that they would appeal to what the people wanted. And the reason Netflix knew what people wanted was because of the machine learning. Um, so uh, what Netflix did was it spent 10% of its annual revenue on machine learning specifically, which is pretty vast when you think about it. Um, and they were determined to have good data. This is one of the keys takeaways that I'm going to mention more later, but they got data from a variety of places. They're the the actual physical characteristics of the movie itself, and they're also able to collect things like viewing time, how often people switched, how often they lingered on a certain image. So those they collect automatically, but they also had hand tagged data where they actually paid people to watch the shows and then answer questions about, well, the plot, the setting, the cast. I think they were even dealing with some color issues, like, the way the scenes were designed. So they had both a lot of automatically collected data as well as manually collected data. And they combined this with they used artificial intelligence to create some data also. Now they combined this with a collaborative filtering where they built custom profiles, and then they were able to find where the similarities were between two customers. And then if a customer that was similar to you saw a movie and really liked it, then that would help them recommend it to you. That's called collaborative filtering. Um, interestingly enough, using machine learning, they also found that there was a close relationship between what people looked at, like the thumbnails. That was like the most important deciding factor for whether they were going to click on a movie and watch it. So Disney was entering this market knowing fully well that Netflix was the dominant force. And if they were going to be able to be competitive at all, they were going to have to set up a really good machine learning and to try to catch up with them. And so the case kind of ended with, the question, will they be able to keep up? So I looked up some recent data and found out that it doesn't look like they have caught up, at least not yet. So these are the latest numbers. So these are the streaming platforms. I took off Spotify because they're huge. But if we look at these, so the dark blue lines represent the number of subscribers in millions, and the light blue bars represent the revenue in billions. So these light blue things are actually a lot bigger, by an order of, a factor of 1,000, but they just fit it this way. So what we see here is that Netflix is still the winner on revenue. And so they had 200 million subscribers and 25 billion of revenue versus Disney Plus. They have 100 million subscribers and 6.9 billion in revenue. So to try to translate this into, understandable terms, I've pulled these numbers into Excel, and I calculated the revenue per subscriber. And as you can see, Netflix is still the winner here. So Netflix is getting about $125 off of each subscriber. Amazon 97, Hulu 74, and Disney 69. So Disney is still playing catch up here. They're still not getting not even close to competitive with Netflix. And I mean, that could just be because they had a lot of catching up to do. Netflix has a lot of expertise, and of course, they have that data. Now, what Netflix doesn't have is the intellectual property. So that could become a factor in the future. So the key machine learning case takeaways. So the value of a machine learning project comes from asking the right questions, right? So Netflix succeeded with machine learning because they said, what is it that we really want to determine here? And what they wanted to determine was, what are good recommendations? How do we make good recommendations to customers? And then all of the good results follow from that. They have more subscribers. The existing subscribers are happier. They wind up getting better content. They're more efficient in terms of production and development of new shows. So it's all downstream of that successful question that was answered with machine learning. Second, often the key success factor is having and obtaining the right data in sufficient quantity. So I pointed out that they had some automatic data, but they also committed a lot of money to just getting data, having people manually just write down, what kind of movie was this? What was the tone? Who were the actors? What was the plot like, etc. Um, and so finally, I think that this is a key takeaway from machine learning is also actually responding to the findings. So it's one thing to build a predictive model, but mostly that's supposed to be for action, right? What matters is the insight leading to some kind of action, some kind of change in decision. And if you could build models all day long, but if they don't actually drive any kind of new action, then they're not really having their value. Okay, so in the discussions, I thought it was really interesting that a lot of people took up this idea of personalization, that you could use, you have existing data, whether it's, attributes about individual people or about individual rides, that we could take that data and then we could come up with a way to personalize something for somebody. We could say, okay, given this person's attributes, we can we can plug their attributes into a machine learning algorithm that could predict something that would be highly personalized to them. So it's very much on this Netflix model. And so I saw a lot of these. So everything from athletic training plans, educational interventions. So based on student performance, what's going to be the best intervention that will help them? Optimizing shopping experiences, admissions outreach. So specifically for university admissions, taking, historically, what has the algorithm found would be an effective way of reaching a potential student, and this would be, you know, this is what the action you would take. So RIDE, estimated time of arrival estimation. So kind of using machine learning to forecast a demand surge. So if the machine learning model says, okay, there's going to be this much demand in this much amount of time, that allows you to deploy whatever resources you need to pick up that demand. And of course, product recommendations. I saw at least one in the apparel industry. And we used to look at a text called about a company called Stitch Fix, where they used machine learning to try to predict the clothes that a particular customer would like, and then they would send them in this box format. And then, of course, machine learning can help you devise answers for chatbots. So a chatbot takes the text that you type in, and it basically does a machine learning classification of what that question was. And based on that classification, it can come up with particular replies. So that's what's going on under the hood with chatbots. Okay, there were also some ideas for using ML for improving operations, so inventory management systems, absolutely. There are certain analytic models for replenishing inventory, the EOQ, for example. But modern methods of using machine learning to predict demand and predict depletion work better and are more accurate. So machine learning for driver, drive route optimization. There was some idea of optimizing the efficiency of processes. So finding out what, using machine learning to predict, the cost of a process and then being able to tweak it so that it's works better. Predictive maintenance. So there's at least a few of you who work in some kind of engineering capacity where you can use you can build machine learning models that can take the attributes of the machine, that is like vibration and heat, and can actually predict when certain parts are going to break. And you can use that algorithm to use proactive kind of maintenance. And then finally, machine learning for recruitment, so college admissions and HR. So being able to match attributes of potential, successful members of the organization so that you can, spend your time going after the prospects that are really valuable. So one thing that a lot of people pointed out, and I think this is right, this is definitely the right lesson. Machine learning can make predictions, but it can't replace judgment. There always has to be some kind of human in the loop, depending on your use case. That may be early on or maybe later on, but nobody said, okay, well, once we have this in place, we're not going to need somebody there kind of managing it. So really what AI is doing is it's scaling expertise. So we have an expert, like let's say a physician, who is able to offload certain tedious tasks, such as creating notes or entering electronic health records, and instead of being able to see, say, 10 patients per day, can see twice as many because they're not spending so much time on those particular aspects of the position. And so what they're able to do is take their expertise that is in the clinical process of interviewing people, and scale that to a larger set of patients. Also reducing cognitive load. So that is if there's tedious tasks that you can offload so that you can spend time doing more value-added activities. Improving targeting and timing. Okay, so like marketing, you can do machine learning to predict the right time in the right market. And then, of course, making organizations feel more responsive. So, being able to predict when customers are going to behave a certain way. There's actually a logistic regression model where you can predict what are the conditions when a customer might be dissatisfied or when they might even quit the service altogether. Okay, so there's a lot of different, real great variety of machine learning, and some insights that were kind of embedded in the discussions this week.